Hey guys, welcome to lesson 7.2, where we look at how to construct a confidence interval for proportion. So let's start with an example. VT Parking and Transportation Office wants to know what proportion of undergraduates keep a car on campus this semester. So we're dealing with answering a question about a population of undergraduate students. The answer will shape how many permits to issue this year. Surveying all 30,000 undergraduates, it's impossible. So the office selects a random sample of 1,500 undergraduates, and in that sample, 90 will keep a car on campus. So we want to construct a 95% confidence interval for the proportion of all VT undergraduates who keep a car on campus. So a few things. What single number our best guess? So our best guess, if we want to know the proportion of all undergraduates, is the proportion of the undergraduates in our sample. So the 90 out of 150. How far on either side of the guess should the interval reach? We'll find out. And what does 95% confidence allow us to claim? It will let us know that we're 95% confident that our interval that we construct will contain the proportion of all undergraduates, the population parameter. All right, so here is the formula we're going to be using: p hat plus or minus z star times the square root of p hat 1 minus p hat over n. P hat right here is our sample proportion. Our standard error is right here, and our multiplier we're going to construct depending on the confidence level. So there's two conditions you need to know for a one proportion z interval. Sample has to be randomly selected, and what's called a large count condition. So the sample has to be large enough. How do we know it's large enough? It's got 10 hits and 10 misses. So a hit is the trait we're counting, and a miss is a trait we're not counting. So in our case, if a student has a car on campus, that's a hit. If a student does not have a car on campus, that's a miss. We need both of those to be greater than or equal to 10. All right, so Z of C we're going to find using the Staplet app. So on Staplet, we're going to go to normal distribution. We're going to set our mean to be 0, our standard deviation to be 1, and we want to find a value corresponding to an area. So depending on the confidence level, well, the value is always going to be central. So let me go back to here. So if I want to find, if I'm looking for 95% confidence in 95% confidence level, I want my central area to be 0.95. And we're always going to use the right hand value. So the multiplier would be 1.96. Three values worth recognizing. At 90% confidence, our multiplier is 1.645. So let me just show that. So at 90% confidence, our multiplier is 1.645. Then I showed you the 95% confidence level, 1.96. And if we want to be, for example, 99% confident of something, that value is going to be 2.576. So those are like standard. That's always going to be the multiplier value when we are looking for a Z interval. So 99% confidence, 95% confidence, 90% confidence. But if you don't remember, I mean, you're not expected to remember those values, but you're expected to use the Staplet normal distribution app to find them. All right, so let's construct the confidence interval. So now we have a random sample. That's good. 150 VT undergraduates, 90 keep a car. All right, so the hits are 90, misses 150 minus 90 is 60. Both are greater than or equal to 10. That's good. Our point estimate is the proportion of the sample that keeps a car on campus. So 90 out of 150, 0.6. The multiplier for 95% confidence is 1.96. So our formula, p hat plus or minus z times the square root of p hat 1 minus p hat all over n. This whole thing is the margin of error. Our p hat is 0.6 plus or minus 1.96 times the square root of p hat is 0.6, 1 minus p hat is 0.4. Our sample size is 150. We could put that into Desmos. Our margin of error ends up being this. So 0.6 plus or minus the margin of error gives us a confidence interval of 0.522 and 0.678. So we're 95% confident that the proportion of all VT undergraduates who keep a car on campus is between 0.522 and 0.678. Here's another example. We have a random sample of 180 VT students. We find that 63 hold a part-time job during the semester, and I want to find a 90% confidence interval for the proportion of all VT students who hold a part-time job during the semester. All right, so if 63 hold it, that means 117 don't. So both of those are greater than or equal to 10. So large count condition is met. Point estimate, remember p hat is x over n, so 0.35. If I'm looking for 90% confidence, my central area is 90%. 1.645 is my multiplier. All right, so 1.645. So p hat plus or minus z times the square root of p hat 1 minus p hat all over n. If my p hat is 0.35 plus or minus 1.645 times the square root of 0.35, 0.65, that's 1 minus p hat, all over my sample size of 180. Again, I'm going to put that into Desmos, but I end up with 0.292 and 0.408 when I do the 0.38 plus or minus 0.585. So we're 90% confident that the proportion of all VT students who hold a part-time job is between my left and right bounds. Reminder, as my confidence level increases from 90 to 95 to 99%, my interval gets wider. So the bigger the confidence, the wider the interval. And the multiplier basically dictates that. As your confidence level goes up, the value of the multiplier goes up, which makes your margin of error wider, which makes your confidence interval wider as well. All right, so let's see. We have a random sample of 160 VT students. Find that 80 recycle regularly. Check both conditions. All right, so it's a random sample. And my hits is 88. My misses looks like 78. Both of those are greater than or equal to 10. So the large count condition is met. I want to find the p hat, which would be 88 over 160. So p hat is 88 over 160, whatever that is to 3 decimal places. My multiplier, z of 95. I want a central area of z of 95. I think it was 1.96. It is. So 1.96. Find the margin of error. Margin of error. So my margin of error, my confidence interval is p hat z of star times p hat 1 minus p hat all over n. All of this is the margin of error. So I would do 1.96 times the square root, and I would put all that in and just get my margin of error. And then my confidence interval would be, right, the p hat plus or minus the margin of error. I get my left bound, I get my right bound. So some key terms, 1 proportion z interval. There's my formula. I'll provide you with the formula on the exam. Hits and misses is how we check the large count condition. At least 10 hits and at least 10 misses are necessary. Z star is the positive value trapping a central area to the confidence level, and we find it using the inverse normal app on Staplet. So summary, 1 proportion z interval is that formula. Check that it's random, check that there's at least 10 hits and misses. Know how to find z-star for different confidence levels using the Statplet app. Make sure you set the mean to 0 and standard deviation to be 1, and then use the central area component. So you'll just be expected to know those steps. Conditions, point estimate, multiplier, margin of error, interval, and interpretation. And that's how we do 7.2.